Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video on mutually exclusive events. So let's look at what those words mutually and exclusive mean. So mutual kind of means the same or acting on each other in the same way. Like if you like a girl and she likes you back, you say the feeling is mutual. You both like each other. And of course, you know, exclude means to stop something from happening. So mutually exclusive events stop each other from happening. Another way to say that is they cannot both happen at the same time. So, for example, the events, I get an A in maths this semester and I get a B in maths this semester, they are mutually exclusive. And that's because they can't both happen. You can't get an A this semester and get a B this semester. If you get an A, you can't get a B. If you get a B, you can't get an A. You cannot have both of these happening at the same time. My team wins its grand final, my team loses its grand final. Another example of two events, one event, that are mutually exclusive. Your team can't win the grand final and at the same time lose the grand final. They cannot both happen, so they are mutually exclusive. So if two events are not mutually exclusive, that means they can both happen at the same time. So let's say I pick a card from a deck. The card is red, I pick a red card, and I pick an ace. They are not mutually exclusive. The reason is these events can both happen at the same time. I can pick a card from a deck that is red, but also an ace. I could pick the ace of hearts or the ace of diamonds. So that's why they are not mutually exclusive. So now let's look at using mutually exclusive events in probability. So if A and B are two mutually exclusive events, then to find the probability that either of them happens, you just add up their probability. So what that means is the probability of A or B. So remember, we've been introduced to this symbol meaning or. Then that is just the probability of A plus the probability of B. So the good news is you've probably been using this formula without actually realizing it. So let's look at this example. I roll a normal six-sided die. What's the probability I roll a 3 or a 4? So note, these two events are mutually exclusive. If you roll a normal die, you can't get a 3 and a 4 at the same time. Just can't happen. So you probably know instinctively the probability you roll a 3 or a 4 is 2 over 6. There are two ways you can roll a 3 or a 4. You can get a 3 one way or 4 a second way, and there are 6 outcomes in total. So it makes sense that it's 2 out of 6. But that's actually using this formula. See, the probability that you roll a 3 is 1 over 6. The probability you roll a 4 is 1 over 6. So the probability you roll a 3 or a 4 is just adding those two together. 1 6 plus a 6 gives you 2 sixths, 2 over 6, or 1 over 3. So what's the probability I roll an even number or a 5? Well, once again, these two events are mutually exclusive. You can't roll a number that is both even and a 5. So, because they're mutually exclusive, the probability this or this happens is just the sum of their probabilities. The probability I roll an even number is 1 over 2. The probability I roll a 5 is 1 over 6. The probability this or this happens, I just add up these two. 1 over 2 plus 1 over 6, and that gives you 4 over 6 or 2 over 3. Okay, that's all well and good for mutually exclusive events, but now what we're going to do is learn how to calculate probability of A or B when the events are not mutually exclusive. So if two events are not mutually exclusive, you use this formula here. Probability of A or B, probability A plus probability of B minus the probability of both. Remember, this symbol means and, A and B means both. So this is actually pretty similar to the formula we had on the previous slide. Remember, this part here in green, That's the formula if they are mutually exclusive. If they're not mutually exclusive, you need to just subtract the probability that both happen. So these formula work, both of them work, because remember, if two events are mutually exclusive, it means that A and B cannot happen at the same time, so the probability of A and B is 0. So when A and B are mutually exclusive, this is 0, so we just use what we have in the green. But when A and B are not mutually exclusive, you need to also subtract the probability that both happen. So let's look at an example. So let's look at this example here. Roll a normal 6-sided die. What is the probability that the number I roll is even or a prime? So let's let A be the set of all even numbers. So if I roll a normal 6-sided die, then I could get, as an even number, 2, 4, or 6. They are the possibilities for me getting an even number. So let's let B be the set of the prime numbers that I could roll. Well, if you roll a normal 6-sided die, the prime numbers you could roll are 2, 3, and 5. So note, A and B are not mutually exclusive. You can have them happen at the same time. You can roll a number that's both even and prime. See, 2 is in both. I could roll a 2, and then I would have rolled an even and a prime number at the same time. So because both of these events can happen at the same time, they're not mutually exclusive. So if I want to find the probability I roll an even number or a prime, remember this is like our OR formula, what I do is just add these two probabilities together minus the probability that both happen. So what's happening here? So if I have the probability of A or B, so the probability of even or prime, so for A, there are 3 possibilities out of 6. For B, there are also 3 possibilities out of 6. But the thing is, if I add these 3 possibilities and these 3 possibilities, the thing is I've double counted the 2. I've counted it here and here. That's why I need to subtract it. So the probability of A and B here is 1 over 6. The probability that I roll a number that's even and prime, there's one number that's in both lists out of 6. So when I'm doing probability of A or B, probability A plus probability of B minus the probability of both. I need to subtract the probability of both because otherwise it's been double counted here and here. So 3 over 6 plus 3 over 6 minus 1 over 6, and that gives me 5 over 6. So the probability I roll a number that's even or prime is 5 over 6. So let's look at just a couple more examples. We'll do them a bit quicker. So let's say I pick a card from a normal deck. What's the probability that the card is clubs or a king? So I'm asked to find probability of clubs or king. So from the previous slide, the formula is I find the probability of clubs, add the probability the card I pick is a king, and then I need to subtract the probability of both of those things happening. So clubs and king, these two events are not mutually exclusive. They can both happen at the same time. I can pick a card that is both clubs and a king, and that's if I pick the king of clubs. So that's why I'm using this formula here. So if I pick a card from deck, the probability it's clubs is 1/4. The probability it's a king is 4 over 52. There are 4 kings in the deck out of 52 in total. The probability the card is both a king and a clubs is 1 over 52. Because that, picking a club and a king, is if I get the king of clubs. There's 1 king of clubs in the deck out of 52 in total. So putting all that in your calculator, you get 16 over 52 or 4 over 13. And that's my final answer. So once again, I need to subtract the probability of both because it's been double counted. I would have counted the king of clubs in this slot here, but also in this slot here, and that's why I needed to subtract it. So let's look at this question here. Probability A or B is 0.3, probability A 0.2, probability B of 0.25. We can actually use the formula to find the probability of A and B. So what we have here is probability of A or B equals probability of A plus probability of B minus the probability of both. We can just use this formula and solve this equation to find probability of A and B. So, of course, 0.2 plus 0.5 is just 0.45. And so, of course, this leaves us that the probability of A and B from this information must be 0.15. Alright, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.